Okay, last time we already talking about the counter. So now we see what happened to the counter. Basically, you get two different type of the counter. Okay, number one, binary counter. Okay, binary counter. They can counting up 0 to any number. Okay, so counting up. And next, they can be counting down. Same thing. You can counting down from any number. Like you're now counting down from 16 to 0 and to 16. Counting up, they can count 0 to 16 and to 0. Keep going. Okay? That's a binary counter. Number two, BCD counter. What the BCD stand for?
Binary code decimal.
Perfect. Binary code decimal. Okay? So basically, this is a binary, but they working like a decimal. That means they can going from 0, 1, 2, 3, 4, 5, 6 up to 9 and go back 0. They cannot higher than number 9. Why? The decimal, same thing. 0 to 9, 0 to 9. Okay? That's the BCD counter. Okay? They can either count up or count down. Okay? So, 2.1. Okay? Count up. 0, 2, 9, 2, 0. Okay? Or count down. 9, 2, 0. And back to 9. That's why you can see what the difference between the counter. Basically, you have to know if you want to counting up or you want to counting down, two ways you can get the output. If you get the input applied to the counter, And you can using PSPI simulation. Okay, so to get the in data, input, output. And you can using PSPI simulation. Okay, 3.1. Okay, understand. I see. To get information. Normally, for PSPI simulation, you given PSPI the input data and you run the simulation. It will be given to you the output. Okay. However, the PSPI simulation we're using for student version, so they don't have a much part in that library. So we cannot run simulation. In that thing, what you can do is try to understand, okay, the input and the output from the information of the IC. So that is the basic for on of the digital lab. Okay, so you get any question or anything? The other thing you have to understand is if you want to count 0 to 1, normally they're building counter by using the flip-flop. And you understand we get only two types of the flip-flop using on the time. That will be the D flip-flop and the JK flip-flop.
Teacher, I have a question. Can you hear me? Oh, creo que no. Teacher, I have a question. Can you help me?
I can hear you, but the professor's doing something right now.
Yeah. Thank you.
Okay, I don't know why my iPad is locked out. Okay, can you hear me?
Yeah, I can. Can you
Okay,
help me? I have a
if you
question.
want to counting from 0 to 1, how many flip-flop do we need to build?
0 to 1?
Yeah, 0, 1, 0, 1, 0, 1. How many
Uh,
flip-flop do we need to build?
we need
Yeah,
only one.
perfect.
Uh,
One flip-flop. The thing is, one flip-flop, they get only one Q. Okay? So Q equal 0 or Q equal to 1. So if you want to build a flip-flop, they counting 0 to 3. How many flip-flop?
2.
Two. Perfect. And if you want to counting from 0 to 16, how many flip-flop?
5, if you want to go from 0 to 16.
Okay, now
4.
4. Perfect. You have
No,
to
because that
remember
doesn't include, that only goes up to 15. If you're going from 0 to 15, you need
0
4.
to 15. Perfect. You're using the formula. Joule power of n. Okay? That means Joule power of 4 equal 16. 16 state. Zero, 1, 2, 3, 15. The thing is, you start from 0 to 15, that means you get a 16 state. Decimal start from 0. Okay? So basically, depending on how many flip-flop, okay, you can see what the number they're counting up. For example, 2 power of 3 flip-flop, you get number 8. So if they count 0, 1, 2, up to 7. Okay? But that's just for your knowledge. You can do nothing with that. And now, in order to do the lab, you get two things must be done. First thing, you have to get your test program using the Visual C++. Okay? ready, the next thing, you have to know how to build your circuit. Okay? And after you're done with your circuitry already built, and now you're using your test program to test the circuit. Okay? And the problem is, if the test it failed, okay, then we get into two problems. We don't know your program right or wrong. And we don't know your circuit you build is not exactly what we want. So you cannot solving two problems at a time. Only one unknown, not two unknown, okay? So that really will be telling you I am working on of the test I given to you. I try to get the execution program. How come? I don't know why, how come? Okay, anyway, we'll find out later. Okay, so what I said, I try to do on of the lab I given out will be get the execution file. You can using that. First thing you can run with your hardware, your circuit. If it passed, that means your circuitry working good. Then now you can using your software, your program to test. If it fails, guarantee some wrong with your software. Okay? And now if you run with execute program and it failed, that means your circuitry something wrong. That's on the way to isolate something wrong with your software or something wrong with your hardware. Okay? And also, I make sure you understand the way how to build the circuit. Okay? Have to build the circuitry the way we want it. If you want me to help you. If you build the circuitry, too many wires running around I don't have enough time to help you. Okay? Try to build it very clean. Then that's easy for me to help you. And that will be the skill you need to learn about troubleshooting. I try to explain to you how come we fix the problem. And you can learning from that. Next time you can do better. Okay? That is the technician job you have to do in a company. Okay? Any question? No?
Can you hear me, teacher?
Yes?
All right. When you talk about the, let me see, the understanding IC to get information is to check the data sheet.
That's what I will be talking about that now. If you cannot run simulation, then based on input from the IC. Okay? And now we'll be talking about that.
Yep.
Okay, now I'm talking about the lab number 6. This lab here, if you're looking into this schematic, how many IC in this
3.
3? U1, U2, U3. Perfect, you get better. Okay? And first one I'm talking about U1. Okay? U1A, U1B, just the U1. What is it?
Buffer.
What is the U1 supposed to be? Counter or whatever. The thing is, I cannot take into every IC. Basically, we learn the way. Okay? You can get the information about that now in the Google. Easy for you to get. You can type in at 74 to 44. They given you all of the information. But I want to know, how to help you to understand. 244, that's just a buffer. Okay? Now, what that mean for a buffer? That means input, output will be the same. Okay? If you get the input, pin 2, pin 4, pin 6, pin 8, and the output will be pin 12, 16, 14, 12. Okay? In and out the same. If you get the input logic 0, output will be 0. Input logic 1, output logic 1, nothing else. However, why we need a buffer? Who knows? Why do we need it?
G input with 0.
And I can telling you, you get a logic 0 and logic 1. Logic 0, that means any voltage less 0.8 volt. That means logic 0. Logic 1, any voltage from 2.4 volt to 5 volt. That's a logic 1. When you measure it on the circuitry, you get a voltage and you come up with a logic. The thing is, when you deal with a digital, you deal with a 1 and 0. Okay? You're not using the voltage. The voltage just helping you. That is a logic 1 or logic 0. And now I'm telling you, why do we need a buffer? For example, pin 1, you get 2.5 volt. What logic?
1.
1. Okay. When you get the output of input pin 2, that means this is the output. They bring it up to 4.0 volt. They still a logic on 1, correct?
Yeah.
However, they prefer logic 1 supposed to be close to 5 volt. Okay? So that's why we need the buffer. We try to bring the logic to the 1 standard logic we want. Same thing. Logic 0. You measure input at the logic 0, maybe 0.5 volt. That's okay. However, when they go through the buffer, they try to bring that logic to close to 0 as possible. Okay? That means they can be 0.2 volt or 0.1 volt. They still a logic 0. So now you understand why they need the buffer. In and out the same, but a different voltage. Okay? That is the key. Yeah.
Just the is the reason why they're doing this is because if you're too close to the border of that separates the logic 0 and logic 1, you might have a variance in voltage that might make it like an invalid input that you don't want in the circuit, or
No, nothing to do with that.
Okay.
Only thing is if you want logic 1, you want it close to 5 volt. If you want a logic 0, you want it to close to 0. Why they need to bring it up to close to 5 volt? The thing is, the signal can be go through too many things else. In the circuitry, that voltage can keep going down. Okay? They don't want that. If they going down very close to 2.4 volt, they can drop it more. That cause the problem. That is the reason why we using the buffer. we want to keep all the time the logic 1 everyone, or logic 0, same thing. That is purpose. Okay? And now you can see in that one you can get, I believe, that 20 I pin input output. That will be 20th. Okay? Normally 20 pins IC, pin 20 will be 5 volt. They need the power. And a pin 10 will be ground. Most of time will be the same for any IC with 20 pins. Okay? If it's less or different, that is, you need the schematic to see. Now, in here you get 2, 4, 6, 8 pin. Output will be 12, 14, 16, 18. That's for 1A. Another 1B, same thing. You can get the input will be 11, 13, 12, 15, 17. And output will be 3, 5, 7, 9. Okay. However, in this IC, you can get 2, 1 here, pin 1. Okay. And pin 19. What happened to pin number 1 or pin number 19? That's what they're talking about. The control, the IC. Pin 1 control for 1A. Pin 19 control for 1B. Okay? For the output equal to the input, then pin number 1 must be ground. Okay? Must be ground. Who knows? If you're not grounding pin number 1, what happened?
The
If
input,
pin number 1 not grounded,
the output is
Maybe a floating voltage values.
that will be
It will be
telling
off.
you. Okay. If you not grounded pin number 1, that will be telling you output, they will be get a big resistance here inside. Okay, that means they try to isolate from the output here. So they cannot loading any current. That is the purpose for pin 1 control. Output will be equal to input if pin 1 is 0. Now, what happened? The same thing in 1B. If 19 is not grounded, output will be not get any logic. They will be open. Okay? That means if the output Y1, Y2, Y3, they inside they get a high impedance. Okay? The purpose is try to not loading any current into the IC. Okay? So normally when you troubleshooting, you measure the input pin 2 at a 2.5 volt and you measure the output, they not logic 1. So you know something wrong. What you can do? First thing, you make sure U1 pin 20 is 5 volt power and pin 10 must be ground. And now you measure pin number 1. Make sure they will be 0. That means they connect to the ground. Okay? Then now the output, you take pin 1 okay, pin 20 okay, pin 10 ground okay. However, the output is not logic 1. Who tell me what you think you can do to solve that problem? What I asking you? You measure the input pin number 2, you get logic 1. When you measure the output pin number 18, you not get 1. You can get anything, but not 1. That means not over 2.4, 2.5 volt. Then I'm telling you, you take the power pin 20, make sure you get 5 volt.
Check the
You
power.
take the pin number 10, they're supposed to be rounded, 0.
So,
Then you take measure pin number 1.
zero.
You're supposed to get 0 and you get 0. However, the output still not logic 1. Who knows?
Change the chip.
Telling me what next to be done.
Change the chip.
Can the IC?
Easy. Change.
Right. You talking about that. That means you're talking about you working in a company. Okay? You can give a this part IC here to the assembler. I want to change this IC. Okay? And after you change this IC, what next you want to do? You try to retest it. If it passed, that means you fix the right thing. However, now I'm talking about the lab you're working in the class. If you measure everything okay, but the output here not okay, you will be change the IC. However, before you want to change the IC, I want to know a little more to guarantee the IC not working. What can you do? Okay, if you don't know, I telling you. How many wire connect to pin 18 here? How many wire?
1.
1. Perfect. I telling you what to do. You can remove this wire, okay, and measure it. If they still not logic 1, then you change the IC. However, if you remove this wire from pin 18 and you measure, okay, and you get a logic 1, that will be telling me this wire must be go somewhere, okay, wrong. So you need to take the wire to fix the problem.
Or the input of a U2.
The thing is, I don't want when you build the circuitry and now you try to running to see the wiring okay or not. We don't want to do that. If you already built, go ahead and test it. Don't try to take anything. Wiring. When you run, they telling you the circuitry connect right or wrong. That's what you try to learn, what they call a troubleshooting. If you already know how to do it, later on, the lab is not a big deal. And you will be very exciting to working on the lab, the thing is.
Where you at, Flame? And someone is crazy where you at, Flame?
I couldn't hear you.
I said, can someone increase the way you are playing it, the pin number? I got pin person that has been tied on it. You tied on file and tied on feed. 2 times.
Okay, just a minute. I try to see I can make the louder.
Got it.
Can you hear me? Okay. Now repeat it. Hello? Hello? Do you hear me?
Yeah, I'm online.
Okay. So we have just bring up the question. Go ahead and try again. Okay. If it's not, I'm telling you again. You get the input is right, output is not right. So what your job will be doing? Just make sure you get the power 5 volt at pin 20. And pin 10 will be routed 0 volt. And pin number 1 by connection here, they supposed to be 0. That means you get the pin 1 is 0, pin 10 0, pin 20 at 5 volt. And now the output input is logic 1, output supposed to be 1, but it's not. In the company, you can let them know you want Gen U1. Okay? They can asking you why you want to Gen U1. You can telling them, I measure pin 2 input, I let logic 1. I measure pin 1. They routed. Okay, however, pin number 18 supposed to be 1. It is not. That's why I want to get. However, I'm talking about the lab you're working in the program. Then you have to do a little extra thing. Remove the wire. Connect you somewhere else. Just remove it up and measure pin 18. If you get a logic 1, they're telling you this wire goes somewhere not supposed to be. Okay? I bring it up to you to make sure. After you build the circuitry, I don't want anyone sit down and wring out the wire. No, that's not a job for the technician.
Hmm.
The job for a technician is find out what's wrong, not wring out on the wire. This is a small circuitry you can ring. Later on, you can get a big one. Okay? But don't waste the time doing something not supposed to do. Okay? Now, pin 1 apply to input U2. Okay? And U1B get from output of U2 and go to port C system. Okay? Very simple. Now I'm talking about U2 here. That's the main thing. This is a 74160. If you go into the Google, you type in 74160, they given you all of the information of this IC. Okay? And now, in order to see how this IC working, Okay. Then we go into that one here. That is the one I want you to understanding. This is the timing diagram for that IC. The first thing talking about the input here, CLR. What that mean?
Club.
Clear.
Clear. Input clear. So if you're looking here, input clear pin number 1, right? Okay, active low. You see to get the bar over on the bubble here. Active low. What that mean? That's telling you want to clear the output of the counter. They must be low. Okay, when they low, they will be clear the output of the counter to be 0. Okay, now if you're looking and going down here, right here, okay, they want to clear, okay, and the output, okay, you can see QA, QB, QC, QD. For output, they supposed to be 0, okay, and now if I'm looking here, okay, you clear, okay, and the output, they supposed to be 0, 0, 0, and 0. Now, what happened to the input? First thing, the load, that's the one input, A, B, C, D, another input, clock, and P and T, that's the input here. Okay, when you apply the clear equal 0, what the load supposed to be?
1.
1.
1. Perfect. That means you know how to read it. 1. And basically input A, B, C, D, they don't care. Okay? Whatever the number. Right now, they will be the number will be 1, 1, 1, 0. However, same thing. When the clear 0, then that's supposed to be don't care. That's supposed to be don't care. That's you don't care. And also, load in here can be don't care also. That means the highest priority will be clear. Clear 0, you cannot do anything. Output must be 0. However, my question is, this already going low. Here. How come QA, QB, QC, QD, they still not 0? If you're looking into that one, who can tell me why? I repeat it. When you get clear 0, how come after that the output Q is still not 0 until here?
Was the club.
Perfect. Yeah, you know what to do. Basically, this IC controlled, okay, also by the clock signal. Whatever you want to do, you need the clock. So if you're looking here, this is the clock will be going from 0 to 1. If you apply clear, they not clear yet until you apply the clock 0 to 1, and now they be 0. Okay, so make sure you understand what I'm trying to helping you. Okay, otherwise later on more and more coming, we cannot keep going back. This is a thing you have to be done.
We can hear. We cannot hear.
Hello?
Yeah, we can hear you.
Okay, I can hear. We can hear.
Oh man, keep giving me a problem here. Okay, now you can see this IC. You get input A, B, C, D, output Q, A, B, C, D, and you will get a function clear. And next function will be load, active load. If load equal 0, then QA equal input A, QB equal B, QC C, QD D. That means you loading any number to the output. Okay? Any number you want. So now, if you're looking on the timing, now you want to load. That means load 0 here. And the first thing you see, clear must be 1. The thing a load is the second priority. Okay? Second priority. Highest priority is clear. Clear 0, Q must be 0. However, if you want to load any number, then clear must be 1. Now, see what number you want to load. You see here the number 1,
Wow.
1, 1, 0. Okay. You know what 0, 1, 1, 1. What number?
14.
Come here. 0, 1, 1, 1. You know this is the
7.
LSB. Least significant. That's why A. That is a 7. You want load number 7. Okay. What happened is when load going to 0 and you need the clock must be 0 to 1. Then the output now will be 1, 1, 1, 0, number 7. You see that? So for any activity on this IC, they're asking for the transition of the clock going 0 to 1. Okay? So now you start counting. Okay? Each time you want to counting. Okay? Then they need the clock transition. And you see up on the top here, load must be 1. Clear must be 1. Okay? When you apply the clock, okay, you see what they coming out. 0, 0, 0, 1. What number?
1.
8.
What
8.
number come out? Number
8.
here, number 8. Okay? And now you apply a night clock. Then they go to output will be 1, 0, 0, 1. Number
9.
9.
9.
Okay? And now you keep apply the clock. Okay, they will be go to next number 0, 0, 0, 0. They go to 0. That means they're counting up. 0 to 9, then 0 to 9, keep going. If you keep apply the clock, okay, they keep running. 0 to 9, 0 to 9. Only up, not down, for this IC. Okay? So you see that, if you understand that, it's very easy to get through it. Now I'm talking about the last one here. Pin 15 on this IC. That will be the output. Okay? That will be carry out. Normally, what the logic of RCO? If you're looking at timing, looking for RCO here. Normally, what logic? RCO.
It's low.
Low, perfect. When they go high, here, right? You see that? When they go to high, okay? So basically, when the counter reach number 9, okay? Counter reach number 9. This output go to logic 1. Then they go back to 0. Telling you what? They're telling you by looking at the output RCO here, I know the counter already count up to number 9. That's just the output to telling the people know. When you see this going up here, they're telling you output of the counter reach number 9. Okay? So, normally, if you want to do to test normally, then you have to connect the oscilloscope to pin 15. So you can see when they going high. Okay. However, this is an automatic test. We don't want to using oscilloscope or meter. Okay. To make sure that go to logical 1. That's why we adding that one. I see. 74. What I see is it?
It's a D flip-flop.
D flip-flop. Perfect. Okay. For the D flip-flop, they connect not Q back into D. That only telling you one thing. When you get the clock, output will be toggle. That means if 0, now they go 1. Or if what 1, now they go to 0. Remember that. For the D flip-flop, if they connect not Q back to the input D, so the flip-flop will be toggle. Okay? Toggle means when they get the clock, so it was 0, now they go 1. It was 1, now they go to 0. So when you try to clear, okay, when you try to clear, this is a clear right here. They go into clear U3A. That means at the beginning, output here will be 0. Okay, when you clear. So when you try to run testing counting up, when the counter up to number 9, so this line here, normally 0. And now when they go up to number 9, they go to 1. Okay, they're telling you the transition will be 0 to 1. Will be the clock for the U3A. So now they will be toggle. So that they will be 1. If the output go to 1 after number 9, I know for sure pin 15 will be working. That everything for this lab. Okay, if you're looking into the document here, TRD, what they want, test load data 0101, test load data 1001, test load data 0010. After that, you test the clear, okay, U2 and U3. That means you apply the clear, okay? So the output here will be 0, and this guy also be 0. Then now number 5, test U2 counting up 0 to 9 and to 0. Finally, you test for U2 output RCO. That means you want to read the data here. Make sure they have to be logic 1. Okay? So try to understand that thing. Okay? This basically, they just try to make sure you know how to enter. If you get the load, for my understand, okay? If you get the load, then load clear must be 1. Load have to be 0. Okay? And enable, they don't care. Okay, load have to be 0. And the clear must be 1. Okay, A, B, C, D, whatever load you want. Okay, so load 0, 1, 0, 1. So 0, 1, 0, 1. Okay, you have to fill in this table until this is passed. That means you really understand how to make it work. And then you can get into port A, what you have to do, okay, for that number 1, 2, 3, okay? And port D, what you need to fill in, okay? And then will be port C. If it passed, that means you're done. And now you're going back into here. If this is a path, then you can upload this file, okay? And now we'll be ready for you to build the circuitry to coding your program. Up until this point, you get any question? Remember, if you already know what's going on, how to do it, I don't care you will be in the Zoom or no. However, if you want to learn how to deal with the problem, first thing, understand the circuitry. Second thing is something going wrong, what you supposed to do. You better in the Zoom. I will be help you out. However, when you testing your circuitry, everything fast, and now I make something wrong. I give it to you example. Okay, I say I short it to the route. Okay. When you run the test, I guarantee it failed. The thing is, you want the RCO supposed to be 0, then must be go to 1. However, we shorted the wire to the route, so they cannot go to 1. What test will be failed? Do you hear me?
Test 6.
When I short this line to route, telling me when we done the test, what test will be failed?
Six.
Test number 6 or what? Now see how many test number. 1, 2, 3, 4, 5, 6, up to 15. You load here, load here, load here, clear, counting up, 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 up. The last one will be test U3 for toggle. So if you sort this to route, guarantee you have a no clock coming here. The thing is they supposed to be 0, then go to 1. However, we sort to route, so they cannot go. So the output was 0 and now still 0. So the test fail will be the test number 15. Okay? So up to the point, you understand. That means when I say I short that to the route, I could be asking you, can you tell me if you run, which test will be failed? The answer have to be 15. That means you understand. Otherwise, still need more. Okay? to learn. So, any question, anything? When you get the problem, the big thing is, I only normally in the class on Monday only. I am the other instructor get too much work to be done in order to run the program. Okay? So, if you get a problem with your software, you get error, whatever, or you run the test, they fail. You don't know your hardware, your circuit board, or your software. You can just text to me. You want to online anytime. You can spend with me just about 20 minutes or less. Then I can tell you what's wrong. It's okay or not okay. Okay, don't waste the time. Otherwise, you cannot get through the program as I expected. Okay? Any question? Anything else? Hello?
No, it's not.
No. Okay. So I will be stopped now. Okay. I wish all of you get a nice weekend. We'll see you on Monday. Okay.
Have a nice weekend,
Bye-bye.
Sam.
Bye bye.
Okay,
Thank you,
thank you.
sir. Bye-bye.
See you Monday.